Okay, so here's example 9 in our complex numbers topic. In example 8, we're going to look at how to calculate the modulus and argument of a complex number. If you haven't seen that one, please go back and look at that because it introduces what these two things are. In the example 8, the modulus, the argument that we had was a first quadrant angle, which is quite straightforward to understand, but you just have to be careful with some of the complex numbers, particularly when the angle is in the second, third, or fourth quadrant. I'm going to explain that. So it's always good to draw a sketch, first of all, of your complex number on a Cartesian Argand diagram. So we've got our two axes, real and imaginary. We're told that the number is 1 minus root 3i, so that's positive 1 on the real axis. The negative root 3, which is slightly bigger than 1 on the imaginary axis, which means that our complex number is going to be somewhere down here. The actual angle doesn't matter, it's a sketch. What it does remind us of is that the argument, when we think about it as being an angle from 0 in that way, is a fourth quadrant angle, all sine, tan, cos. However, we calculate the modulus and argument always in the same way. We can say that the modulus is the square root of the real part squared plus the imaginary part squared, which in this case the real part is 1 and the imaginary part is negative root 3. Remember, don't put the I term in here, otherwise your answer is going to be really not right. So it becomes 1 plus, watch this one, negative root 3 times negative root 3 is positive 3. So we've got the square root of 4, which means our modulus is 2. Always positive, although root 4 is usually plus or minus 2, the modulus cannot be negative because it represents a positive distance from the origin. Okay, now let's look at the argument this time. So the inverse argument theta is inverse tan of b over a, which is the imaginary part, negative root 3 divided by the real part, which gives us the inverse tan of negative root 3. So we're looking for an angle for which the tan of that is negative root 3. If the tan is negative, then it tells us that it must be in either quadrants 2 or 4. But from our diagram, we can clearly see that it is the fourth quadrant angle. If you were trying to find that on a general trig equation, we would be looking for the acute angle, which is the positive version or the acute version of inverse tan of root 3. We know that the tan of 60 degrees is root 3, 60 degrees or pi over 3 radians. So that would be the first quadrant angle. But we know, if we didn't know that it's quadrant 4, we would say either the angle is pi minus pi over 3 or 2 pi minus pi over 3. We would give two possible angles. But we know there is only one because the diagram tells us a fourth quadrant angle. So we write down fourth quadrant angle. So we only need to do one calculation, which is the 2 pi minus pi over 3. We don't need to consider the second quadrant angle because we know it's not that. 2 pi is basically 6 pi over 3, depending on how you calculate your angles. And that becomes 5 pi over 3. So in this case here, the modulus is 2 and the argument is 5 pi over 3. And so our Cartesian Argand diagram also kind of doubles a bit of as a quadrant diagram, if that helps you. But it's really important that it helps to identify which quadrant the angle is so that you can do your calculation. Okay, so practice doing these kind of things, and then we'll talk about the fact that sometimes we don't actually use big angles in our argument. we often get to a point where anything over 180 degrees we view as a negative angle. We're going to talk about that in the next video, but for the moment, if you can get yourself sorted at finding the modulus and the argument in that way, that would be great.